Good morning, everyone. My name is Kyle Escamilla, and I'm the training coordinator for EandM. Thank you for attending our Learn in 30 webinar today focused on SICK picoScan. After the webinar this morning, we'll be doing a short Q&A, so please type any questions or comments into the Q&A box and we'll get to them at the end. Now I'd like to introduce your presenter for today's webinar, Akshay Bhati. Akshay is a product specialist here at EandM. Good morning, Akshay.
Hi everyone, good morning. My name is Akshay Bhati. I'm the product specialist over here at EandM for NorCal region, and I look after SICK and robotics. So today I'll be going over a product called SICK picoScan LiDAR. This is a newly released product in our portfolio, and I'll just start and look into it. I'll start with the presentation first, and then we'll jump into the live demo. Okay. So SICK picoScan. So like I said, this is a newly released product. SICK already has few LiDARs in their portfolio, which are really good. And the one closest to this product is called TIM LiDAR. It has been in our portfolio for many years, and it's very good product when it comes to like raw data, ranging data, or field evaluation. But now SICK came up with this new product, which can be called successor because it's close to the TIM LiDAR, but has better performance. And the sole reason why SICK came up with this new LiDAR is because we want to future-proof our LiDAR portfolio. So we want to introduce new technology and make it just better at a similar price point. So on the right side is our TIM LiDAR. That's an outdoor LiDAR from TIM 7 series or 5 series. And on the left side is the new product, which is called SICK picoScan. So as you can see over here, it is triple in performance, means some important specs are more than triple, and it is compact in size, so very crucial when it comes to robotics application. And again, we are also keeping pricing in mind and making it, and we are offering it at a similar price point as TIM LiDAR. So what do we mean by triple performance? So I'm talking about the working range. It's the scanning range of the LiDAR, that how far can the LiDAR see an object. Then it's the angular resolution. So angular resolution is basically what is the angle between each pulse when it's emitted from the LiDAR. And scanning frequency is how fast the LiDAR is doing how fast the LiDAR is doing a complete scan. And measurement data quality is basically how the raw data looks like when it hits an object, whether it's reflective, dark, black. So in those cases, measurement data quality is very important. Now, talking about the form factor, picoScan is slightly smaller. As you can see over here, our TIM family is 60 by 60 by 86 or 79. But when we talk about the outdoor variant, which is the gray one, it's slightly larger than the picoScan in terms of height. And the third one, like I said, we are keeping price in mind. So this is a cost-effective new product. So this is a SICK LiDAR portfolio. As you can see on the top, that is the safety rating, which is PLD. So we currently have 2 scanners, NanoScan 3 and MicroScan 3. We have more like outdoor scan, but yeah, over here we are just talking about safety rated indoor scanners. And then the next one is PLB. We have ScanGrid, TIM LiDAR, and picoScan safety will be released soon. Then we have the raw data LiDARs, which is this portfolio over here. So this blue one is indoor, this is outdoor rated, and these are the bigger ones. So we had like a gap between our small LiDAR and the larger one, because small LiDAR has a limitation of 25 meters of scanning range. If we need something more, then we have to go with these bigger or bulkier LiDAR. So that's why we kept that in mind and released our new product picoScan, which can bridge the gap between this one and this one over here. So we have 3 variants in this family. One is the core, which is lower in price point, doesn't have very high performance, but that doesn't mean it's not good for basic applications. It's a perfect solution when it comes to short range applications or just basic raw data mapping. But when we need something more advanced, like a faster LiDAR or better angular resolution, then we go with the picoScan Prime, which has slightly better specs compared to the core and has a slightly higher price point. And the top one is picoScan Pro, which has almost all the features and add-ons of the picoScan family and would be a perfect solution when we are talking about complex high-end navigation applications or outdoor applications where there's a lot of harsh environment condition. So the next one, this slide is more about this important specs, which makes these LiDAR different from each other. As you can see, the working range of core is up to 25 meters, prime goes up to 60 meters, and pro goes up to 120, which is a lot when it comes to this form factor or this size of LiDAR. Then another thing which is important when you evaluate a LiDAR, it is the 10% range. So other competitors might just give you the maximum range, which can be very high, but the true test of a LiDAR is done on a 10% reflectivity, which means if the target is black in color, which absorbs maximum light. So that means only around 10% gets reflected back to the LiDAR. That is when the true range of a LiDAR is evaluated. So in our case, when there's a dark black object which absorbs almost 90% of the light, our LiDAR gets 12 meters in core variant, 25 meters in prime, and 40 meters in pro, which is a lot when it comes to black objects. Now, the next one is angular resolution. Like I said, it's the angle between each pulse. So as you go higher in the variant, the angular resolution gets smaller, which means finer or cleaner data and high precision. Scan frequency, again, as you go with the variant, it goes maximum to 50 hertz. So that's the fastest scan frequency in this portfolio. And then we have some additional sensor apps or packages which can be selected based on your application, which I'll go through in the later slides. So data streaming and field evaluation. So data streaming is basically just the raw data, what you get out of the LiDAR. And then we talk about the field evaluation, which is again, it's more of like you can draw fields and monitor an area. If you get an object, it triggers an output. So rest are almost same. The one thing which has to be noted here is the system plug. So this LiDAR has a system plug which can be removed. And let's say if your LiDAR is damaged, you order a new LiDAR, you just have to use the same system plug and you get all the configuration. You don't have to configure the LiDAR again to make it work in the application. So again, that gives a lot of flexibility. Then we have some features like dynamic sensing profile, where LiDAR resolution changes based on the object dynamically. We have multi-echo, where we send multiple echoes at in one scan. So very useful when it comes to harsh environment. We have IMU that gives you basically the orientation of the LiDAR as it's moving. So very useful when it comes to navigation and floor is uneven. Then we have reflector recognition. In some cases, let's say LiDAR is being used on AGV in a warehouse. So there are reflectors installed so that LiDAR can localize itself if the objects around it keep changing. So in that case, reflector can be recognized using reflector mode. And then we have a data reduction package that's more for cleaning the data. So instead of cleaning, like removing the noise yourself, we can use this package and it does the cleaning on its own. And then we have reliability package that's more for outdoor environment. Again, some false trips can be avoided using this package. This is the system plug. Like I said, system plug can be removed. So that's there. And then in future, we'll have CAN interface, USB-C, and automotive Ethernet. For now, we just have regular IOs and Ethernet. Our LiDAR can also be also be connected using IP address through the browser. So you don't have to have a software installed to access the LiDAR. So that gives you a lot of flexibility. Then we have some mounting brackets. This is a basic mounting bracket. This is more for alignment, and this is when it comes to outdoor. This is like a shaded bracket which protects the LiDAR from rain and direct sun, things like that. Okay, now let's get into the demo over here. So just give me a second. So I want to show you a few things in our software, and then you'll understand what I'm talking about. So this is my LiDAR setup over here. This is my picoScan. That's the new LiDAR. This is TIM LiDAR, which is a predecessor. It's still in the portfolio, works well, but I just wanted to do some comparisons so you understand how this is future-proof. So I'll share my screen by which you can see the software as well. Second. So this is the software I was talking about. Sorry, IP address. So I just keyed in the IP address. I press enter. I can access my picoScan LiDAR over here. This is the raw data. So first thing you can see in this LiDAR, this is the raw data points of the LiDAR from the surrounding environment. Like over here, there's a black chair. Then these are walls. If I open the TIM LiDAR, as you can see, these points are moving. So that is basically noise. It doesn't mean TIM LiDAR doesn't perform well. It is a very good LiDAR, but little bit below as compared to picoScan. So this moving points means there is noise. But if you see in picoScan, there's no moving points, like it's close to zero. So that means noise is very less. And when you see our competitors, these points will be moving way beyond what it's moving over here. So that's called noise. Another thing to note, you can see these reflections or these things moving. These are basically spikes which LiDAR gets from corners or reflective objects. But in the picoScan, you don't get any of these spikes because the data is cleaner and stable. So that's another advantage. Now, if you go into the LiDAR over here, these are just some basic settings. In our LiDAR, you can select what angular resolution you need and what's the scan frequency. And if you use the dynamic mode, this gets changed automatically, and I'll show what that means. So over here, so I have this black, as you can see in the camera. So I have this black diary over here. I keep it in front of the LiDAR, which is the picoScan. I'll zoom in, as you can see in the software. So this is my black object. If I change the resolution to a smaller, or let's say to a larger one, the points change or gets reduced. As you can see now, there are more points because the LiDAR has finer angular resolution, means it can see the black object better. So this change in resolution happens on its own based on what the object is. So that is called dynamic sensing profile package. Again, that dynamic change happens on its own only if you have that package. So that package is very useful when it comes to navigation and you have, reflectors or shiny material, black objects, and a varying environmental condition. So that is something which can be very useful. With other LiDARs, you're just stuck with whatever is spec'd in the LiDAR, and it has to go through it, whatever it is. So that's an important feature or very good benefit of picoScan, that you can have it being changed on its own. So another thing to notice over here is multi-echo. That comes in this part over here. So right now, as you can see on the camera, that's a black chair. So black chair is kept over here. Like this part over here is the black chair. So right now I'm getting all echoes, but I can select either first echo or last echo. Now what that means, um first echo means LiDAR emits a first pulse and then emits second pulse and third pulse. So either we select all echoes, means all the echoes are coming back, or we filter the echoes. This is very useful when it comes to, let's say, outdoor environment where fog or mist particle is there, and we don't want the LiDAR to sense it and trigger an output. In that case, we'll just select last echo, means whatever the last echo which penetrates the fog particle and gets to the object and gets a trigger, that's what we care about. So let's say in this case, as you can see in the camera, this is the plastic, something transparent. So if I put it in front of the LiDAR, you can see the black chair looks green. That green means last echo. So one echo is the blue one, which is this plastic material or a fog particle, and the one behind it, it's in green, that's the last echo. So again, this feature is very useful when it comes to, let's say you have an environment where there are glass doors or glass objects, or like airport, you have to monitor people away from, like, beyond the glass door. So that's where this LiDAR or this feature is useful. Or then we are talking about outdoor environments, we have to ignore fog. So that's again where, we select what echo is required, first echo or last echo, things like that. And when we talk about IM LiDAR, we don't have this feature. So that means this black chair is there, and if we put a plastic here, so it would think that's an object. It cannot ignore plastic or glass doors or things like that. Again, picoscan cannot ignore too, but it's just that we have this multi-echo and we can filter it based on the echoes. So now this doesn't mean TIM doesn't perform well in outdoors. It's also a very good LiDAR. We have particle filter package and different things, but yeah, a little bit lower compared to picoscan, but still superior as compared to our competitors, because they don't even have this reliable data when it comes to black objects. So another thing which you have to keep in mind is we have something called terminal. So if you go over here, there's this tool called terminal, by which you can talk to the LiDAR, get the raw data out of the LiDAR and see it. Usually to access that raw data, either you have to have some kind of converter or wizard to read it. But in our case, in our SIG software, we have we have the thing called terminal. So let's see what is the IP address and, port number of the LiDAR so that we can access it. So I'll go in data output over here. Over here, this is the format of the measurement data. LMD scan data is our typical SIG LiDAR terminology. So very useful when it comes to SIG drivers, because we already have some drivers on GitHub. So it makes it easier for customer to interpret the raw data. As you can see, it's port 211. We'll talk through ASCII to the LiDAR. So what I'll do is first I'll establish a connection. So I'll add it over here, select Ethernet, go next. Pull A and B, that's again a SIG language. And then I'll enter the IP address of the LiDAR. 211 is the TCP port, as you saw it over here. 211 for ASCII. So I'll select that, finish. Now device is connected. So let's talk to the LiDAR and see if we are getting a response. So if I type a command, but before that, we have to change our ASCII format as well, because right now it's in hex. So if I select ASCII, change the data format to Ola ASCII over here, and now I can talk to the LiDAR in ASCII format. So I'll give a command called SRN. This command is for identifying the LiDAR. I'm saying, hey, identify yourself. So when I send device ident, I'll send it and I should get a response. So green is the command sent from the software, blue is the response from the LiDAR. So as soon as I sent it, I got a response SRA device ident 8 picoscan 8 1.4.1. So it's telling its name and the serial number and the firmware. So let's say, you know, these LiDARs, we keep upgrading the firmware. So if we want to know what is the firmware which the LiDAR is on, so we type SRN firmware version. We sent it, we got a response firmware version 5 1.1 1.4.1. So that's the way how we talk to a LiDAR. Now let's talk to a LiDAR in terms of the raw data. So if I send a command srn lmd scan data, so when I send it, it does one complete scan and then gets a raw data to us. So as you can see, this is the raw data. It's hard to interpret, but I can help you understand it. So for example, this is just few things about the device, but now the next one is distance one. That's the first echo. If we go down, we'll see more of it. It's a long string. So there'll be another thing called distance two somewhere here. But yeah, like I said, it's a long string because in one scan, it's getting all the data from it. So now in distance one, if we go, we have to look for something which is, similar or something which is matching. So I can see 4AA, 4A4, 4A5, these things are matching. So let's say I'll take one of this 4AA and see what that means. So I'll go here, convert it from hex to decimal, 4AA, convert 1194. That means at 1194 millimeters, there's an object in front of the LiDAR, and these are different return values from that object. So that means, like I said, at 1194, 1200 or close to that, if you take the average of all these data points here, you will get to know what's the exact distance of that object. So these are different values from different objects which LiDAR sees. So that's how you interpret the raw data. Now, going back to the LiDAR itself, these are few basic settings like filters over here, fog filter, moving average, particle, again, very useful when it comes to outdoors. Another thing which I have to show you to you guys is the mounting or something called IMU. So this LiDAR has a IMU inside it. It gives you the tilting angle, like if you can see in the camera, if I move the LiDAR to the left or right, that this angle changes based on the tilt. Now, this angle change is very important because let's say if you have this LiDAR installed on an AGV or a robot and the floor is not uniform, in that case, there'll be an angle change. So this IMU gets that angle change, sends it to the LiDAR, which changes your raw data value. That way you don't get like incorrect values from the LiDAR. So again, very important feature. IMU is already built in. It gives you the tilting like this. As you can see, if I move this LiDAR, this bubble goes here. If I tilt it the other way, it goes there. So it's a good tool or a feature to make sure the LiDAR is uniform and, uh, at a flat surface. Another thing I would like to show is the field evaluation. So this is how we draw the field. This LiDAR also has something called floating field. Usually in time of flight LiDARs, we have fields which comes back directly to the LiDAR. Like you can see over here, these two fields. Now, since with this new picoScan, we installed something called floating field where you design a field in the space. So that means anything before that field, it won't trigger an output. As you can see, my hand is here, but the field is away. But if I go in that space, then only it triggers an output. So anything between the LiDAR and that field, it won't trigger an output. Again, very useful feature if you want to monitor something away from the LiDAR, but you don't care about surrounding things close to the LiDAR. So that's a good thing. Another thing which I would like to show you is the output feature. Let's say once we draw these fields, if we go in data output over here, sorry, over here, inputs and outputs. So we have each pin assigned to different sources. Like over here, I've said protective field. I can add another field over here called, let's say, float field. So both the fields can be attached to a single pin. I can AND it or it or XOR, whatever is needed. Put a time delay and then get an output. So again, this is beneficial if we need more fields, but we are limited on the IOs because usually each field is connected to a pin, but in this one we give you this flexibility where you can add multiple sources and connect to one single pin. So very useful. The last feature I want to highlight is the contamination. So this is our contamination feature. Um, usually LiDARs in the market, they don't have contamination, or even if they do, it's on the complete LiDAR. But in our case, let's say if we care only about something being sensed in the front, because that's where we are monitoring the area. So in that case, we just activate like the section 3 or 4, whatever is needed. Only in that case, only these two will be monitored, and others, whatever, if there's dust or whatever, it just ignores it. So it gives user a lot of flexibility in terms of contamination too. Your LiDAR won't just stop because there's dust on this side or that side. So that's another plus point. That's it. Thank you for your time and have a good one.